Hello, I welcome you all. The problem reads, the thrust on the 4 megagrams rocket sled is shown in the graph. Determine its sled's maximum velocity and the distance the sled travels when t is equal to 35 seconds. Neglect friction. This problem is coming from the Engineering Mechanics and Dynamics, 14th edition by RC Hibbeler. So we have the weight, we have the normal force. So this is our W, this is our N. Now we're going to use the concept of linear momentum and linear impulse. So we know that the area under this graph is equal to the impulse. So the question here is to determine the velocity at t equal to 35 and distance traveled. So for the distance traveled, we need to compute this individual because it's not continuous. We have two different functions here for impulse. So we have from 0 to 25 and from 25 to 35. So we need to calculate this separately for us to calculate the distance. So let's start with calculating the velocity. We can use just both graphs. So we're saying integral of f dt is just going to be equal to m v final minus v initial. Right, so our v initial is just equal to 0. We have m equal to 4 to the power, times 10 to the third kgs. Alright, and let's work it out. What else do we have? We have t equal to 35 seconds, and therefore f dt, this is just equal to integral from 0 to 25. Do it in parts. This is kilo, so we'll say by 10 to the third by 4t to the power 0.5 dt plus 10 to the third times half. Let's start with half. So we have two areas. We have this one here with this one here. So this is just half by 20 by 35 minus 25 by 10 to the third. This is equal to m, which is just 4 by 10 to the third by v final minus 0. Right. Therefore, our v final is just going to be equal to, let's work it out. So we have, so we can work out this one. So we know that this just becomes 10 to the third by 4t to the power 1.5 divided by 1.5, evaluating this from 0 to 25, and plus half by 20 by 10 to the third equal to 4 10 to the third v final. Right, so of course this can cancel out. Right, then we have v final is just going to be equal to so we have 4 by 25 to the power 1.5 divided by 1.5. So 4 by 25 to the power 1.5 divided by 1.5 plus 0.5 by 20 by 10. Okay, then divided by 4. So we have the final velocity, which is just 108.3 0.33 meters per second. This is very high. So once we've done that, let's now find the velocities for area 1 and area 2. And from this, we know that our velocity is just equal to ds dt, and our ds can be written like so. Integrate on both sides, we'll have s integral v dt. Okay, so we have the first one from 0 to 25. Then we'll have, we'll call this s1. The other one we'll have from 25 to 35. Okay, we'll call it s2. Then we'll sum up the two. If you don't want this, you can integrate. You can also incorporate the initial boundary at 25 so that we sum them up together in advance, but it's really up to you. So let's work them out. There we go. Let me just create a bit of space. Okay, so let's start. So what do we have here? We are integrating. We're using the same concept. Integral of f dt. This is just equal to integral from 0 to t. So I want to write v as a function of t, because we'll later on have to have it integrated. Then we have 10 to the third, then 4 t to the power 0.5 dt. So this is equal to m, which is just 4 10 to the third by v, I'll call it just v1 minus 0. So working out this, our v1 just becomes equal to, I can cancel out this part. This is not minus, this is just a third. So I can cancel out this and this. Then we have 4 times 1.5, 4 times 25 to the power 1.5. You can integrate that on your own. We've already done it in the other one, so you should be able to do it even yourself. Alright, so velocity at that point is 83. Is 83. Once you calculate, is 83.33 meters per second. In the first area there, we'll have that. Sorry, this is being expressed in terms of t. I'd replaced t already in advance, so let me just rewrite it. Sorry. So this will have a 4t to the power 1.5 divided by 1.5, 0 to t, equal to 4 v1, and therefore our v1 is just going to be equal to, so even this and this cancels out. Okay, so this just becomes 1 divided by 1.5. Okay, I'll leave it like this. I'll just say 1 divided by 1.5 t to the power 1.5. So it remains like this. Okay, so 1 divided 1.5 times 25 to the power 1.5. Okay, so this remains like this, but we know that v1 at 25 seconds gives us 83. Okay, we need to use this later on in our second case. So this is from interval t from 0 to 25. Then we go to interval t from 25 to 35. Alright, there we go. Let me just write it down here. So we'll have t, that is 35, so 25 to like so. So what do we have? So we are integrating again here, f dt like so, integral from 25 here to t, see the second interval of this. Let's work out this function here. We can work out this. This is t, function of t. This one is equal to, let's work it out. So we have t equal to m t plus c. Our m is the gradient, which is just change of t divided by change of small t, and there this coordinate here is 25, 20. Then this one here is 35, 0. Alright, so there we go. So we'll say a 20 minus 0, and this is 10 to the third divided by a 25 minus 35. So this is just going to be equal to 20, 10 to the third divided by 10 minus, so this just becomes a minus 2, 10 to the third. So this is our gradient. So if you picked one point, let's take that one there. So this just becomes 0 equal to minus 2, 10 to the, not to the third, just to the third, just a gradient to the third, then times t. Our t there is 35 plus c. Okay, therefore our c is just going to be equal to 70, 10 to the third, right? 2 by 35. Alright, and therefore t is just going to be equal to minus 2, 10 to the third t plus 70, 10 to the third. We can try out this one. If we are to plug in 25 there, we should be able, if you plugged in t equal to 35, what do we get? We get a 0, right? And the y-intercept there is going to be, so if you plugged in minus 2 by 25, okay, a third plus 70 times, alright, which is a 20. So it is working. This is the equation. So let me just move it a little bit there. So this one is t, function of t, this is equal to minus 2, 10 to the third t plus 70, 10 to the third. Okay, alright, this is in newtons. If I just wrote it in terms of kilonewtons, I'll just write it as minus 2t plus 70. Okay, and this one is in kilonewtons. Okay, that's one and the same thing. So once we've done this, that's the equation that we intend to use. Okay, so here we'll say 10 to the third minus 2t plus 70 dt is equal to m, which is just a 4, 10 to the third, then we'll call it v2 minus v1. And our v1 here is equal to 83. So let's write it down. We do have already the v, so this is 4 10 to the third. Then we'll say v2 minus 83.33. Okay, so we can cancel out this and this. So to rewrite this, we'll have a minus 2 divided minus 2t squared divided by 2 plus 70t. We are evaluating this from 25. These are the boundary conditions to t, and this is equal to 4v2 minus 4 by 83.33. Therefore, this becomes minus t squared plus 70t, okay, plus 25 squared minus 70 by 25 equals 4v2 minus 483.33. So v2 therefore is just going to be equal to minus t squared plus 70 70 divided by, so this becomes 0 plus 1 divided by 4, 0.25 t squared minus then plus 70 divided by 4. This is 17.5 t, and then later on we have 25 squared minus 70 by 25 plus 4 by 83.33 and everything divided by 4, and we have a minus 197.92. If we plugged in 35 here, if we plugged in both of them, v2 at 25, we should be able to get 83. If we don't, meaning our equation is not correct. So v2 by 25 squared plus 17.5 by 25 minus 197.92. So we have 83.33, which is okay. And then v2 at 35, we should get this one here. If we don't get it, it means our equation is not correct. Minus 2.25 by 35 squared plus 17.5 by 35 minus 197.92. So this we get a 108.33. Okay, there we go. So we have the two equations. And these are fine. So we are going to use this equation now. We know that our v is just equal to ds dt, and therefore our ds is just equal to v dt. We integrate on both sides. We have s equal to integral of v dt, and our s here is just going to be equal to s1 plus s2. Or if you don't want to, you can just use the second equation with the boundary condition s1, so that you don't have this. But for me, I'll calculate them separately. So s1 therefore for me here is just going to be equal to integral integral of from 0 to 25 of v, and our v here is just 1 divided by 1.5 t to the power 1.5 dt. Alright, so our S1, if we calculated this, which you can do on your own, this just becomes 25 to the power 2.5, okay, divided by 1.5 times 2.5. Okay, so this gives me 833.33 meters. I check it again. So 25 to the power 2.5 divided by 1.5 by 2.5. Right, so let's go to the second one. S2 is just going to be equal to integral from 25 to 35, and the equation is a minus 0.25 t squared plus 17.5 t minus 197.92 dt. So this you can integrate on your own. I'm going to just integrate it also here directly using my calculator. So minus 0.25, okay, times 35 to the power 3, okay, divided by 3 plus 17.5 times 35 squared divided by 2, then minus 197.92 times 35. Then we can say minus, I'll bracket the rest, again minus 0.25 times 25 to the power 3 divided by 3. Then we have a plus 17.5 by 25 squared divided by 2, and minus 197.92 by 25, close brackets. So this one gives me a 999.97. Therefore, my S is just equal to S1 plus S2, which is just equal to 833.33 plus 999.97. Let me check this once more again. I think it looks fine. So 833.33 plus 999.97. This gives me total S is just equal to 1833.3. Okay, right, meters. Right. Okay, I think this is about it. We found the velocity at t equal to 35 seconds, and we found the distance covered. Okay, right. I think this is about it, and I hope this particular video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.